Hey guys, I want to make a video for a design project pitch. Okay, and so I've prepared a presentation, and I normally would have liked to give this to you in person, but due to the circumstances of us meeting only a couple days a week, it makes it a little bit challenging. So I'll give this to you virtually, and then I will give you an opportunity to ask questions because there's going to be questions, even if it's something personal related to your own project. I would encourage you to ask. All right, so please advocate for yourself. All right, so this is kind of challenging for me to talk about, but this is a big design project that's going on in my life right now, and it's due to some events that happened kind of recently, and I've been thinking a lot about this. Many hours of thought went into this, and it's time to put my thought into action. So I want to share with you my design project of something that, like, this is true to life. This is going to happen like very soon. So I'm going to go ahead and share my screen here, and I will start a presentation. And so I'm going to kind of do like I'm going to kind of do like you would do, more like a presentation to me, but I'm going to kind of like do a presentation and then talk a little bit about, like, what's important, what you should hit on, and I want to give you some information about, like, how would you go about doing this. Okay, so I just want to describe to you my design project, and I've prepared this presentation for you. So this is me, a picture of me in 2016 at the Chet Atkins Appreciation Society, and I am playing a historic guitar. And this was Chet Atkins, and most of you don't know who Chet Atkins is, but he's a guitarist. Back in the 1950s, he is passed on, but he is basically my hero. And so somebody who I aspire to be like, somebody who I aspire to play like, just a wonderful person. And so made a lot of beautiful music. And so here I am. I got the opportunity to meet with a guy. His name is Tom Doyle, and he owned this guitar, and it was a really famous guitar that Chet Atkins in the 1950s they were developing this guitar, and they were trying to make an instrument that would behave a lot better than acoustic type instruments on stage, because acoustic type instruments can feed back and do a bunch of stuff, do a bunch of things that are not wanted when you're on stage. So what he was doing was trying to modify the guitar and make it more stage friendly. And so this was kind of one of the early prototypes to what is called the 6120 model of a Gretsch. Okay, and so guitar playing is my life. Aside from being a teacher, it's my life, it's my passion. I love to do it more than anything to do anything else. It's my passion. And so I had something happen to me that I'd always feared. I'm also a woodworker, and I had an accident in my shop, and I lost half of my ring finger. And this was something that happened about almost 2 months ago, and I'm still trying to cope with it and adapt with it. And so ever since I was laying in the hospital trying to recover, I've been thinking about ways that I can still play guitar. And so I was thinking about ways that what chords I would be able to do, and what things wouldn't I be able to do, and how could I adapt. And so there are still things that I can play without much trouble, but there's definitely a deficit, and something that I want to figure out how I can play those things again. And since I don't have part of that finger, it makes it very difficult. And so chords requiring 4 fingers are no longer possible, for me. And there are some songs and a lot of tunes that fit into that category. And so here's a picture of Chet Atkins playing Cascade, which is a monster stretch. in the guitar, and it's something that I've always worked on, not really all that hard, because the first part of it is really challenging. And so, but there's part of that song that I'll never be able to do again. And so, and as much as that breaks my heart, it also inspires me to think about ways that I can do the things that I used to do. And so what I want to do is I want to build a device that will assist me in doing 4-finger chords. Okay, so let me tell you a little bit about it. Here's what I need it to be, and I forgot to put the little blue X on an animation, but I'll tell you about it. So here's what I need this product to be. Okay, so the device must be able to control each string, because chords, you know, they're all sort of different chords, and due to the situation that, you know, I'd be playing all sorts of different chords, I need to be able to control the pitch of each string. Okay, so I need to control each string, and the device needs to be able to bend the string up one whole step. So if I look at this C7 chord here, this is like a guitar fretboard. All right, so if I look at the C7, I have the number 3. That would be this is not how I used to play it. How I used to play it would be number 3 would have been my ring finger, number 4 would have been my pinky, but now I can't get to that. And so what I now have to do a C7 chord, which is so common, and I miss doing this chord shape so much, you have no idea. I have to bar, well, if I had the device, this is how I would do it. I would bar the first fret, and bar means like I lay my finger all the way on the first fret and cover all of them, okay, cover all the strings. And then what I would do is have my pinky to do that third number 3 on the diagram, and I'd have my middle do the second. But now I need somebody to do the 4. And so where the 4 would come in is on this device that I would be able to bend up the note from the first fret all the way to number 4. Now I know if you don't play guitar, this probably doesn't make any sense to you whatsoever, but this is what I needed to do. And if it bent the string up one whole step, then I'd be able to do a C7 chord without much trouble, okay? Which is something that I can't do right now. So I need a way to bend the string up one step, make it tighter so the pitch changes and goes higher, okay? So I would also like to be able to bend the low E string down a whole step, but I'll maybe tackle that later. So there are a whole bunch of different devices, tons of different devices to be able to bend guitar strings up, but typically they're only like one string, like a B string or you know, a G string bender, okay? So I need something that can do all the strings, right? That's just not good enough for me, okay? And so what I have this picture of is, this is a product called the Hipshot, and they've got a pretty cool idea where you can bend the B string up. When you pull the guitar towards you, it hits a lever, and the lever is attached to like a, you know, the string, and then when you pull the lever up, it pulls the string up and makes it tighter. They also have what are called palm levers, and palm levers are something that when you press the palm lever down, it'll bend the string up. Okay, it's a real simple mechanism. But for my style of playing, I cannot have palm levers. Okay, no palm levers at all. They get in the way of my playing. I can't have the same feel. I can't have the same dynamics go. It's just not possible. Okay, so I need something that happens with foot pedals. Okay, that's what I want. And here you see this device here. This gentleman's playing a guitar with all these cables attached to it, and then there's 6 pedals on the floor. That's what I need. Okay, so this is a project constraint. By the time that I get done with this, this is how it's going to look like. All right. Here are some other restrictions. Okay, these are other constraints here. I need these guitars to attach to. I need this device to attach to certain types of guitars. All right. The people that have done this before have attached it to. If you look on the right-hand side here, this is a Gibson Les Paul. Okay, and this This is an electric guitar. I don't really play Les Pauls much. This is a Telecaster. I own several Telecasters. I love Telecasters. But this kind of idea has been utilized in these two types of guitars. Okay, now it's much easier to do this on these types of guitars, but guess what? This is not what I needed to do. I needed to attach to Gretsch style guitars. Okay, and you see here these two guitars on the left. These are guitars that I own. Okay, I own a red guitar. It's a Country Gentleman. I was playing this at my wedding. And then an orange guitar, which is a 6120. And so you can see that the way that the strings attach on this guitar is different than the two guitars on the right. Okay, the two guitars on the right are solid bodies. The ones on the left are more archtop guitars. Totally different ball game. Okay, so I need a device that's going to attach to these style of guitars. Okay, well, how do we do that? So where do we actually attach to? What my thoughts are is that I need it to attach to two different types of Bigsby vibrato systems. Okay, if you look back on these guitars, the vibrato systems are attached to like the bottom of the guitar. Okay, it's like where the strings attach to. All right, so that's where this device is going to attach to. So I needed to attach to two different types of vibratos. A B7, okay, which is on these two types of guitars. Those are B7 vibrato systems. And then I have a Telecaster. It's a custom built thing. A friend of mine did this for me. And it uses a B16 Bigsby. Okay, and a B16 Bigsby is a little bit different because you see here one of the pickups actually like gets mounted inside this whole aluminum housing. Okay, it's super cool. I love this system. It's great. It's fantastic. All right. So I need this device to attach to both of these things. Okay. And so how are we going to do this? In 1960, there was a patent that was applied for, well, actually it was applied a couple of years earlier, but it got approved and everything by a guy named Tommy Terman. And he was out in California and he was making his living playing guitar. And he wanted to sound more like a pedal steel guitar. And so he wanted to be able to bend the notes to sound more like a country western steel guitar sound. And so he actually came up with this idea using motorcycle parts. Okay, like the cable, you know, your brake cable it's got a cable that runs down to the mechanism that actually stops the wheel, right? So he thought, well, if I just attach a cable to the string here and pull the string back a little bit, I can actually get it to bend. Okay, so it's a great ingenious idea. It was the first time that this has ever been done, especially with these devices, these Bigsby devices. And so he came up with this idea. He pitched it to the guy who manufactures these Bigsby vibrato systems, and Bigsby actually made about 20 of these. Okay, so they went through, did some design work, figured it all out, made them, and then, but they only did about 20 of them. Okay, so the reason for that, I don't really know, but it just didn't take. They didn't think maybe it would be a high seller, so they didn't manufacture it much. There's just a handful of them out there. I found a guy who has one of these, one of the original ones, and I had him send me some pictures of the unit. And so, as well as I actually tracked down and hunted down the actual patent that was applied for. And you see on the left here, this is a plan view of the mechanism from the CAD drawings that were on the patent. Okay, and you'll see all these numbers on there. That's due to like descriptions in the patent, right? So like these number 16s, when they're talking about the string in the patent, you know, they can point to the diagram which has the number 16 on it. So it's just easier to read. All right, so here's the idea, basic pulling mechanism. All right, this is generally how it works. Okay, you got a cable that's attached to a device on a string, and it rotates about the bar that the string's attached to. And when you rotate it, you tighten the string, making it higher pitch. Okay, so this is in general how it's going to work. Okay, but the difference between my design and this design, I'm going to steal ideas from this, but this design is only made for using one string to pull. I need all 6. Okay, so I got to adapt this and make it pull all 6 strings. Let's look a little bit more at this pulling mechanism. So where the actual bending happens is right around this bar. Okay, you can see the circular attachment that slides onto the bar, and you actually attach the string to it. And then with this little ball and socket connection here, you rotate it down to fit on the socket. And then when you push the foot pedal, it'll pull the socket towards you, or towards the pedal mechanism. And then it'll actually raise the pitch of the string. Okay, and you can see a cross-sectional diagram of how this actually works. And you'll see that there's a top plate. Okay, if you see, look at this diagram in number 42, there is that's a top plate. That's what like mounts the cable to the guitar, and it holds it to the guitar. All right, so that's something that I'm going to have to modify quite heavily to be able to fit 6 of these on there. Now, continuing to talk about my design here, so there's basically 2 halves of this. One half is the connections at the guitar end of things, and then the other half of this design is actually looking at foot pedals, okay, and how we're going to design that mechanism. And so basically what I want to use in my pedal design is a basic L-shaped pedal. And here you can see I've just kind of mocked up a drawing in PowerPoint here. You can see the cable to the guitar is kind of on the shallower length of the L, the lower length of the L. And when you push down on the pedal, it pivots on one point, and it pivots about this point right here. And when you push down, the other end goes out. Okay, and so when it goes out, then it pulls the cable. Okay, so that's the idea. That's the mechanism of actually like pulling the pedal or pulling that cable to actually pull the string. All right. I like this design. I'm going to steal some ideas from it, but I don't like the shapes of the pedals. So what I want to do is have a little bit of a wider surface area, or more surface area on the end of the pedal, so that your foot, you know, has a better chance of hitting it and not sliding off. So this is a pedal that back in the early 70s and early 80s, pedal steel company called Showbud was using. And I like this idea. And you can see this pedal is very, very similar in concept to what I want to do. That circular tube portion is the pivot point. It has that kind of ribbed connection up here where you attach up a cable, and then there you go, you're off and running. You're pulling the mechanism back and forth, right? So that's how I want to do it. There's going to be some modeling that's going to go into this, and I haven't gotten into the modeling yet, but here's what I anticipate. Okay, so I plan on modeling these parts out with Autodesk Fusion 360, which is a 3D modeling software. And so basically I'm going to need to model 4 different parts of this project. One, I'm going to need to model the actual circular bender attachment, because I need to figure out the diameters and get it all right. And I'm not exactly sure how I'm going to machine number 7, actually it'd be like number 56 or 72, I don't know which one, 56 or 72, where that like ball attachment, I got to figure out how to machine that. And I'm not sure yet if that's a part that I can buy, or if I have to make it from scratch. So I'm going to need to model it out and figure out the sizes, the dimensions, and make sure that things are going to work. I'm going to need to model out the cable pulling mechanism, because I'm at mercy of the parts and pieces from the cable company, because I'm going to have to work with what they have available. And so I'm going to have to kind of figure out, you know, what I can do. And so I'll model that out. I'm also going to need to model out the top plate, the one that actually mounts all the cables to it, all of that. And then I'm probably going to model the foot pedal assembly too, and figure out how that's going to work. And so there's some design issues. If you look here, this would be a lot easier if the cables just went straight out the back and out to the guitar. But I like this idea of having the cables exit on one side of it. It makes it more complicated, but I think aesthetically it'll look better, and also functionally I think it'll be better, because then they'll be able to route directly to the guitar, and not have really extensively long cables that are going all over the floor. But with that, I'm going to need to figure out how to change the direction of that cable pull. And so I'll probably need to be using some pulleys in there and figure out how to change the direction there. You can see I mocked up just a little idea of that. And so I'm going to have to figure that out. How's that all going to work? So some resources that I'm going to need. This one is resource heavy, because I could send it out to a machine shop and have these parts manufactured for me. But honestly, like, I'm not exactly sure how they're going to work, and I want to be able to make like prototypes, and I want to be able to put them on the guitar and see how it's going to work and how it's going to function. I want to optimize my design. And when you talk about a lot of back and forth like that, that tends to be a lot of money with the machine shop. And then it's a lot of coordination, and it's a lot of like sending CAD drawings, and because they need to be communicated with and know exactly what I want as a product. And so what I want to just buy the machines myself and do it. And so these machines are a little bit, they're a lot smaller than a real machine shop would have. And so here's what I'm going to need. So I'll talk a little bit about the parts first. I'm going to need some stainless tubing to do that bender mechanism. I'm going to need some cable, bulk cable reel with some various fittings so that I can cut the cables to whatever length I want, and also be able to do, figure out how to do the fitting attachments. And I'll probably need a crimping device to be able to do that. I'll need some sheet aluminum to do the top plates. I'm going to need a bending mechanism to be able to like do a 90-degree bend. And then looking at the foot pedal assembly, there's a whole bunch of metal in there. Okay, I'll need various aluminum bars for the pedals. I'll need sheets for enclosing the whole thing and doing that. Tools. This is where the fun happens. I'm going to need a couple tools to be able to do the machining of these small parts. Okay, for example, the bender mechanism is a circular device. And so whenever you deal with circular devices, you machine those with a lathe. Okay, and so this device here is a lathe, and I'm going to need one of those to be able to manufacture those small pieces that go onto the bar and pull the string. Okay, so I'll also need the tooling packages that go along with those. The tooling packages are like the basic tools and stuff that like you're actually using to cut the metal with and shape the metal with and do some threading. Like, it's the stuff that you need to use the machine. Okay, so I'll need a tooling package. I'll also need a mini mill to make some of the slots in this bender mechanism. And so I will need that device also with the tooling package. And I'm thinking that I'm going to need a rotary table as well, which is a device that attaches to the mini mill, and it allows you to spin the workpiece that you're milling in different directions so that you can mill in certain areas. So the third thing that I want you guys to consider when you're doing a pitch is like space. Like, how much space are you going to need to do this project? This one is actually kind of a space heavy project. And so it's something that we need to think about when we do a pitch. To be able to use these machines, they need to be set up in a location where you have power, where you have space, where you can make a little bit of a mess, and they're away from classrooms so that you're not making other teachers angry with you. And so I'll need some space to use the machinery to do the different parts. I'll also need a workbench to do all the guitar setup and all that to get things just right. All right, so these are the resources that I'm going to need. Cost estimate. This is the next part that needs to go into your presentation. There are many parts that are going to go into this project. Honestly, ones that I still have not foreseen. And so to be able to give you an exact number of how much this is going to cost, I'm not there yet. And I don't expect you guys to be there yet. All right, but we need to know in general, what are we getting ourselves into? All right, so what I did is I put cost estimates for generally all the different pieces in this project. Now, I don't have every nut and bolt listed out. Okay, if you were going to go into production and do this to mass produce, like, let's say 1,000 of these things, you would have everything mapped out. And so the machines are going to cost about $1,000 for each machine, the mini mill, mini lathe. A couple $100 for freight. I want you to consider shipping costs as well. The tooling packages for the lathe, $225, mill $325. Then raw materials. This is the one that's difficult to really estimate how much is that going to cost, because I don't know every nut and bolt, every piece that I need yet. And like I said, this is a design project and it's a pitch. All right, I don't expect you to know every single detail out there. That's the stuff that you're going to figure out along the way. But the more that you can foresee, the better off you are. Okay, so I'm trying to think about what materials I'm going to need: cables, fittings, stainless tubing, aluminum, bars and sheets, hardware, whole bunch of different stuff. Okay, paint I'll probably need, and I'm just throwing out a number. I think maybe about $350 for that. You know, I don't know exactly, but I want to account for those raw materials. Okay, so we're looking at a cost of about a little over $3,000. All right, so that's what we're getting ourselves into. So at this point, the presentation is over. Okay, I've given my spiel. I've given what I want to be able to do for my project. And now what I would do is I kind of step back. You know, I'd probably be talking to you throughout this presentation too, for, you know, things that come to my mind. And really, it's a conversation between you and I. And I don't want this to feel like a Shark Tank, you know, where it's like I'm gonna like say absolutely not and send you home and never talk to you again. No, that's not how it is. Okay, so this is a conversation. Okay, if we need to make tweaks along the way, then we make tweaks. All right, so this project is it's complex, and like it's something that I've really been thinking about a lot. And so a lot of this stuff probably just went right over your head, a lot of the technical details, but I want you to put, you know, some of that thought into your project. Okay, if you're going to be devoting a lot of time and energy into this project, like I want you to really think about this and make sure that, for one, this is the right project for you, that this is something you're passionate about, that you're wanting to do, and you're going to be fired up about it. Because when you start hitting those roadblocks, if you're not fired up, if you don't have the finish line in mind, you know, it's going to be difficult to get over those roadblocks. And you better believe when I hit those roadblocks, I'm going to work my tail off to figure out how am I going to get past this. And you know, that's because like I'm super fired up about this project. I'm ready to just dive right in. Okay, and I don't even know, you know, half of I got to learn all these different skills. I have to learn how to use a lathe and learn how to make threads and you know, make my own parts. Like, I've never done that before, right? But you better believe I'm fired up to do it. And so I want you to put a lot of thought into your project before you actually give the pitch, right? So the pitch, you know, actually this took me quite some time to set up, all right? And so that's the idea, okay? I want you to put some time in to be able to get to know your project and get to know, like, what are you actually doing? And so make sure that you put some time into this because the more that you do, the more that you're going to understand your project in the long run, and the more you're going to foresee things that could be hurdles and could be roadblocks, right? So let's run through the slides. Now, obviously, my presentation is not going to look exactly like yours because the content is different, right? I'm doing a guitar-related project. You're maybe doing some other project, robotics, whatever. It's going to look different content-wise, but here's the big pieces that need to be there. Number one, all design projects start with a problem. Okay, you're trying to fix something that's broken. You're trying to make something better out of, you know, your life or somebody else's life. You're trying to solve someone's problems. You're trying to improve the quality of life, essentially. Okay, and for me, this would improve the quality of my life. You have to identify constraints. What do you need your project to do? Okay, and in this case, I outlined all of the things that it needed to be, right? Because this defines the project. This creates the vision. This is like what I need it to be in the end. All right. So identify as many constraints as you can. Okay. So I broke my constraints up. This is not going to be something that's probably going to fit on one slide. Take your constraints and break it up into like categories. Okay. So the categories that I broke it up into is how does it need to function? How does it need to work? Okay. You don't have to figure out like how it's going to like actually function like mechanically, but this is what you need the device to do while you're playing guitar. Okay. That's how I thought about it. How does it need to function? What actual guitars does it need to attach to? Okay. This is another category that I broke my constraints up to. And then how does it actually attach to the guitar? Okay, so I'm constraining this whole project to say it's gotta fit on these devices. If it doesn't fit on these devices, it's a failed project. It doesn't work. Okay, we need to go back to the drawing board and figure out how it's going to. Then talk about your design. You've talked about the problem. This is the issue that's making everybody's life complicated. Talk about what you need it to do. I got this idea. This is what it needs to be. Now we talk about your design. How are you actually going to solve the problem and stay within those restrictions inside your constraints? All right. So here, I guess I didn't really. I did categorize this, but I think I forgot to update one thing. So the pulling mechanism. It's Tina. The pulling mechanism, the cable attachment, and the foot pedals. Okay, so there's basically two different designs, the pulling mechanism and the foot pedals. Okay, so looking at how those work, you know, and again, you don't have to know every single detail of how this is going to work, okay, but you need to have a general idea of what you want, and you got to have a good starting point to go after. Now, am I going to hit roadblocks? Yeah, definitely. Okay, am I going to have to like tweak things a little bit? Absolutely. Hopefully, I don't have to tweak things entirely. That's the idea. You put in the legwork to make it so that you make small tweaks rather than huge tweaks, functional tweaks that you have to go back and redesign everything. All right. Then talk a little bit how you're going to model this. Okay. Then talk about the resources that you're going to need. Okay, what are the actual parts and pieces that are going to go? What am I going to need to order for you? And then how much is it going to cost? All right. So I hope you guys found this helpful. I'm going to put this this presentation up on Schoology for you. You can use it, but again, content is going to be totally different. But I want you to use that structure. Okay, those big ones, those big slide ideas that we talked about. All right. I will, of course, keep you guys updated on this project, and please feel free, ask any questions. If you want to get involved, let me know, and you know, we can figure out some stuff to get you involved. All right, take care, guys. See ya. Great. Don't say anything. I haven't stopped recording. That was my wife, by the way.